So quiz 5. For this one, this is an allylic radical or allylic molecule pi bond, and there's a allylic position, one allylic position with NBS. So NBS, we should know what NBS does. We're gonna get to something at the end of the day that looks like this. All right, we're gonna get the allylic position. It's great. So the first step is we're gonna break this nitrogen bromine bond. So that's the initiation step. The Br dot is going to take the H from the allylic position. The reason why it's going to, as a propagation, make a new radical, that's going to be because we're going to make a more stabilized radical here. So it's a little different than what we've seen before. We generated HBr, and that HBr is going to allow us to generate a small amount, right? So now we're using all of a sudden 2 electron arrows, so protonation. We do an addition, elimination type step here. The bromine reacts to the other bromine. So we make a small amount of Br2, just a small amount, which then reacts with the initial radical, right? And makes another Br2 dot, which then can go back in and do these kind of things. So we make a really small amount of Br2, and that's how this one works. So some resonance structures here. I was thinking people would use the radical, but some people called my bluff and didn't use the radical, but it's okay. I think most of them did it right, but I wanted you to do single fishhook arrow resonance type forms. So you see the radical, the nitrogen has a radical here. Be really careful about where you bring these together, right? Don't have this out in space. You need to show that there's 2 electrons in this pi bond, and one of them is going to be forming a pi bond here with this electron. So you got to be really careful about where your arrows go to make sure you're doing it correctly. And then, right, these resonance for radicals is really 3 arrow processes when you're breaking these pi bonds. But again, carefully put these things where they're supposed to be. That's the only thing I could say to caution is people, just make sure you're not sloppy and you're doing a good job of showing where the electrons are going. So retrosynthetic analysis from starting materials to products below. So again, I need to emphasize this. Folks will really worry about these type of problems because they're very difficult. But if you spend a lot of time just studying this, that's not a very good strategy. The best way to study for these problems is actually to remember the other reactions and study the mechanisms for other things. Because to do these problems, you have to have a good grasp on everything else first. So the way I would have approached this problem, so I would have looked here and said, okay, there's 1, 2, presumably, 1, 2. I need to add 1C. I start with an alkyne. I'm probably going to need to do some sort of, right, deprot the alkyne, terminal alkyne. So, I'm going to do some sort of SN2 with this maybe, right? I can see that the bromine, both of them are on the less substituted carbon. So that makes me think anti-mark bromine add, and that makes me think of, hopefully makes me think of NBS. All right. And I see this OH and a bromine right next to each other, right, like this. And hopefully that makes me think of, well, it could, bromonium ions maybe, right? The Br next to the OH like that, right? And again, this is a lot to take in. It's not easy to do. But doing some of these simple things and trying to think about it will help. Again, challenging problems. That's what they are. So if you looked at this, you recognize these 2 things. You take one step back. You say, oh, that was a alkene because I added 2 things across the alkene. This, how did I get the bromine in the allylic position? That came from this alkene, the bromine. The alkene came from the alkyne, so it had to be reduced. So I put Lindlar's catalyst. And then the carbon had to be added from the alkyne, the first step, the first step going forward. So we start with this. Deprotonate, SN2, Lindlar's, NBS gets you there. Br2 and water. Water adds the more substituted carbon. That gets you there. And this is just one way to do it. One way to do it. People were really creative. I'm just looking for good logical thinking here. Not for the mechanism. I'm not asking for the mechanism. I'm asking for reagents and thinking through things in a logical way.